Hey, Team Impact. You're watching this video today because I'm out. I told you that I was going to be out. Changed it up a little bit. We are going to move on. We're going to move on to box plots, and box plots really really relate to the measures of variation. If you remember what that was finding the median, the first, the third, and the IQR. We're also going to take this and we're going to make a box and whisker plot. So this is more statistical data. Today we'll be doing this. Tomorrow you will be doing two digital activities, and con will start up again for tomorrow. So don't forget to do your con for tonight. It's due on Friday, but we're going to get rolling on lesson 7. So sit back, take some vocabulary in. It's something new, which is always cool, right? A box plot displays data distribution using five key numbers. The difference between the first and the third quartile, we know as the IQR, right? And I'm just going to write that interquartile range, right? All right, so let's identify some pieces down here. The smallest piece of data is called the minimum. MINIMUM. I always misspell that. The median of the lower half, all right, is called the first quartile. You know that, right? We've had that. The median of the midpoint is it's the median, right? It's the middle number. Remember, we have to list the numbers from least to greatest. The median of the upper half is the third quartile, QUARTILE. And the largest piece of data is the maximum. You max out, right? MAXIMUM. All right. So let's talk about this and identify what we have here. And what we have down there is called a box and whisker plot. We have a box and a whisker here and a whisker here. So let's start with down here. This whisker, and a lot of times what I'll do is put a period there at the end. This whisker is the minimum point of the data. So this whisker, I know, and I can't get specific data from this, just like a histogram, but I know the smallest number here is about 2. This line right here represents the first quartile, and I'm just going to call that Q1, okay? And then you can imagine that this line right here represents the third quartile, which I'll call Q3. So Q1, when I look at this, looks to be about, 11, 12, somewhere in there. And this third quartile looks to be about 16, right? Well, of course, this is the maximum, right, where that whisker ends out, and that would come down, and that might be about 17. And what do you think this line of the box represents? It represents the medium, MEDIMUM. All right, so, sorry, MEDIAN, I apologize. IAM. Okay, so let's talk about this. So when we break down a box and whisker plot, 50% of the data is represented by the box. Remember, the first and the third quartile and the median. This would be 25% of the data, and this would consist of 25% of the data. Now, the reason why this whisker is spread out more than this is because we have a bigger spread of data, right? We have more variability, where this is a smaller piece, okay? All right, well, hey, let's get started, and let's make a couple box and whisker plots here. What do you say? All right, so first thing we're going to do is we got to organize our data. So I'm going to go ahead and write 34. What's next here? 45, 48. There's a couple. Oh, no, there's a 47. Sorry. There's a 47. Sorry. So 47, 48, 48. Okay, 49 and a 50. All right, so what I would do here is I would get organized, and before I started to make my box and whisker, I would go ahead and identify my key pieces that I need. So here's the median, here's the first, and here's the third quartiles. Minimum and maximum. All right, so let's go ahead and fill in what we know. The minimum is 34. The first Q1, first quartile, is 45. The median is 48. The third quartile is 49. And the maximum is 50, right? So we've still got organized. So now we're going to take this stuff and put it into a box and whisker plot. You ready? Okay. So what I like to do is start with the median. The median is 48. And let's put a check mark by it. So here's 48 right here. So I'm going to put a line just like we had up there. And then I'm going to go to the first quartile, which is 45, and I'm going to put a line, right? And then the third quartile is 49, and I'm going to put a line, and then I'm going to connect those. And if you recall from the previous piece up here, the box is 50% of the data, and there it is. This first whisker is going to go clear down to 34, so I like to put a dot and then just connect it. And this whisker is going to go up to 50. And you can see why, right? So you can see that this whisker has more variability because it's longer. And there you have it. Okay. Box whisker plot or box plot. Different names by different people. Next up is another piece of data. Let's go ahead and design it. We have a 7. We have an 8. We have a 9. Let's get rid of that. Do we have anything else here? Another 9. And I saw a 10. And an 11 and an 11. All right. And then there's a 12. 14. 15, 15. I'm going to have to come down here, which I don't like to do. 16, 19. So we're going to go ahead and find our median, okay? So let's go ahead and do that. 9, 15, 10, 15, 11, 14. Uh-oh, there's 2 numbers. Okay, so we know, and let's fill in what we know here. 7 is, and 19 is the max. The median is, 11, half of that is 11.5, right? Okay, so let's find that first quartile. So the first quartile, I start with that 11. It's not the median. Remember, it's 11.5. 7, so 11 and 8. There it is. And that's a 9. And then the third quartile, same thing. 12 and 19, 14 and 16, and it's 15, right? Okay. So that was kind of hard. I don't like to do it that way, but I didn't want to write it down here because that's where my box plot's going. Okay. So I start with the median of 11.5, right? And let me pause here for a second. I think I made a mistake. So I did make a mistake, and I apologize. 11 is the median. I redid it, and I looked at my answer key, and I saw something was up. So it's 11 is actually the median, right? 9 is still my first quartile, and my third quartile is still 15, but it wasn't 11 and a half, it was 11. So I just went back and checked my work there, and I saw I made an error, which is okay. All right, so the median is 11, so I'm going to put a line right there. The first quartile is 9. I'm going to put a line right there. The third quartile is 15. And there we have it. I'm going to take this down to 7. And this up to 19. And there's our box and our whisker plot. Do you need those periods? No, but it's nice to have there, right? Okay, let's continue on. Use the given box plot to determine the, all right, so the minimum number looks like to me it should be 11. Maximum is, let's call that 18. Again, it's hard to get specific data from a box plot, except for a few certain things. All right, so the median is 14. All right, so this looks to be about 12 as the first quartile, and this looks to be about 16 as the third quartile. So we can get that information. 50% of the data, the median, the maximum, and the smallest, right? Okay, good stuff so far. Let's keep rolling. Okay, so we're getting into the next piece. It says we're going to use your knowledge here Christina conducts a poll To determine the number of colleges high schools apply to, she creates a box plot. Okay. Determine the range of the data. So range has always been the same, right? It's big minus small. So I think that's 9. So it's 9 minus 0 is 9. 9's the range, right? What is the median number of colleges applied to? Well, that's clearly right there. That's 6, right? All right, next one up. What is the interquartile range of the data? So that's the first minus the third, or 8 minus 4 is 4 colleges. Which quartile represents the greatest spread of the data? Okay, so let's talk about this. We talked about this being 50%, but this is a quartile, the first, right? This is one here, this is one here, and this is one here, quartile force. So which one's the widest, the biggest spread is the first quartile right there. That is the biggest spread of data from 0 to 4. That is the biggest spread or variability of data. So when we look at that, that's important that you understand it. That has the biggest deviation, right? Number 8. Describe why quartile 1 is larger than 4, and why do you observe, and what do you observe about quartiles 2 and 3? Okay, so the reason why 1 is bigger than 4 is because 1 is bigger than 4 because Pecaus, because the spread is bigger. Okay, the spread is bigger. So there might be 5 numbers from 8 to 9. There might be 1 8 and 4 9s. Here there might be a 4, a 3, a 2, and a 1 and a 0. So the spread of the numbers is bigger. These are clustered, those are not. And then what do you observe about 2 and 3? Well, 2 and 3, I'd say 2 and 3 are equal. They're equal. Yeah. Okay, we're rolling right along. Good lesson here, huh? You like this? Hope so. Number 9. The average monthly rainfall during the summer months and winter months are shown below. 1. The range in rainfall was 12. Okay, so we've got to kind of read down through that. It's 15 minus 3. Yeah, 15 minus 3 is 12. So I guess we want to put true there. I'm going to put the answer there. So 12, and that is true. All right, true or false? The median rainfall for the summer was 13. That's false. No, the median's right there. It's 11, so that's false. For half the months in summer, the rainfall was greater than 11 inches. Yeah, because this is a fourth of the data, and this is a fourth of the data, and a fourth is a half, and that takes us out to there. So that is true. Last one. For half the months in winter, the rainfall was less than 10 inches. Well, here's winter. Here's 10. For half of them, yeah. Let's see here. For half the months, there it is right there. For half the months in winter, yeah, because this is still a fourth, and that's a fourth and a fourth. So that's also true. That's also true. So pretty good lesson today. Hope all that made sense. Your homework is here. Take your time. Okay, we're going to hit this again on Monday when I get back. Have a good day, guys.